Okay, this is where we stopped. So we analyzed the algorithm of merge sort and we come up with this kind of Tn. And this is not what we really want to have because we are expecting a Tn to be a function of n. So, but now what we have is we have a Tn in a recursive form. And one thing I want to say is, well, it is common, especially if you are analyzing a recursive algorithm, and then you will end up with a recursive definition of Tn like this. And this is not the only type, and here are just a lot of different types of the Tn you may see. And for this type of the recursive definition of the Tn's, and our question is, how do we go from this recursive version of the Tn and then come up with a non-recursive version or a polynomial version function of n so that we can move on and study the big O, big omega, and then eventually the big zeta, right? So what is this process? This process is called solving recursions. Okay, so our goal is we want to grab a recursive definition of the Tn, and then we come up with a equivalent polynomial version. Okay, there are three major ways to solve recursions. We can do substitution, iteration, and then in the next class we are going to do the master method. Okay, so the substitution. Well, the idea of the substitution is, as you may observe, to solve the Tn, what do we have to know? We have to know how we can do the Tn divided by 2. Okay, so to figure out Tn, we have to figure out how to do the Tn divided by 2, or half T half n, right? So how do we do the T half n? So if we plug in the n divided by 2 into here, so we should replace out this n and this n and this n by n divided by 2, and then we plug in the Tn divided by 2 here, n divided by 2 here, n divided by 2 here, and we will have this. So this is the Tn divided by 2. So we just substituted the n with n divided by 2, so we got the Tn divided by 2. And after we have the Tn divided by 2, we have figured that out. However, inside of the Tn divided by 2 here, we have a Tn divided by 2, n divided by 2. So that is Tn divided by 4. But anyhow, by doing the substitution, we are one step closer to our goal, which is to solve the Tn. And okay, so this is our problem again. How do we solve this? And I'm going to show you a way different to the version on our textbook. This is a project I learned from my professor. Well, I believe he is already retired, because when I was in college, he was already a really old professor. So I think he's retired. But this way, his way that he told me was so useful that whenever I'm doing this kind of problem, I come with this way. Okay, so the very first thing is, well, we want to divide our working space into two parts. The left part is the real problem solving part, and then on the right part, we are doing some scratching to help us do the substitution. Okay, so the master part or the main part will be the left part, and we are solving the Tn. Okay, and to solve the Tn, we observe that inside there is Tn divided by 2. So how do we figure out Tn divided by 2? So we are substituting this n with n divided by 2. So we are replacing this n with n divided by 2 and this n also with n divided by 2. So we get this one. So this is how we solve the Tn divided by 2. So since we are able to solve n divided by 2, okay, so we go to the left side. So on the left side, okay, I'm just replacing the Tn divided by 2 with this part. I just grab this and then put it into the left part. So I want to massage that a little bit and move on, and I got this version. So 4t n divided by 4 and plus 2n. Okay, now we have another question. How do we solve Tn divided by 4? Okay, and then we go to the right side again, so we do some scratching. So Tn divided by 4, so we are replacing this n with n divided by 4. So we got Tn divided by 4 equals 2t n divided by 4 divided by 2 again, and then this should be n divided by 4. Okay, so we have figured out Tn divided by 4. So we go to the left side. On the left side, I'm using the blue ink because this is just a copy and paste. And after that, I want to massage this a little bit, and this is what I have. So 8t n divided by 8, and then plus 3n. So we go from 1n to 2n to 3n. And at the very beginning, we have 2, and then we have 4, and then we have 8. And for this term, n divided by 2, n divided by 4, n divided by 8. So we can continue to solve n divided by 8 and like this. But, well, if you have already seen this pattern, and how about we just replace the 2 and then 8 and 4 with a pattern. And the pattern should be, well, on every level, we are doubling this number 2, 4, 8. And we are also doubling this number, n divided by 2, n divided by 4, and divided by 8. And we are increasing this number by 1n, 2n, 3n, right? So you see the pattern? And after you see the pattern, and you can come up with this. So if we go down and down and down, well, k will be a larger number, but the pattern will be the same. The pattern will be 2 powers k and t n divided by 2 powers k, and then plus kn. This is the pattern. Okay, so if you are able to come up with the pattern, the next question is, if we are here, and where do we stop? There's gonna be a stop point. Even if this is a recursion, there's gonna be a stop point. So in a recursive algorithm, where do we stop? You gotta know the answer. The answer is the base case, right? So what's the base case? The base case is when n equals 1, and then the cost will be a constant, c. Okay, this is what we want to replace. So eventually, when this value is 1, and we stop. So if this n divided by 2 powers k is a 1, and this means k is log 2n. And when k is log 2n, we stop, right? And how about we just substitute this k with log 2n, and what do we have? So k with log 2n, k with log 2n, and then this k with log 2n. And then I massage this a little bit, and then I'm going to replace the t1 with c, and eventually I got this. So n log 2n and plus cn. Okay, what do we have? Now, we start from a polynomial version of tn, and then eventually we go down, and we have a polynomial version of the tn, and we are happy about this. And then we have a polynomial version of the tn, and then we can figure out the big O, we can figure out the big omega, and put them together. We have the big zeta, right? So for this one, well, the easy version is, well, we want to check which one is more significant, or which one grows faster. And in this algorithm, and we will see, okay, this n log 2n grows faster than the cn part. So we are grabbing this one, and we will see this is a big zeta n log n algorithm, and then we are done. Okay, so well, in this video, which I show you the first way to do to solve the recursion. So to solve a recursion, I mean, I come up with a recursive version of the definition of the Tn, and then I want to find an equivalent non-recursive version of the Tn. And this process is called to solve a recursion. And the number one way we learn is the substitution method, and this is a very handy one, especially if you're working on this working on a piece of paper or the whiteboard, and you will find this approach is really very handy. Just cut your working area to two parts. On the right part, you do the scratching, you do the substitution, and then on the left side, that is the main working area. After you figure out one substitution, you plug it in to the left side. Okay, this is a very old professor's way, and then I learned that from him. Now I'm teaching that to you guys. Okay, I will continue in the next video.